With that, I'm super excited to get kicked off with Solandy, who's going to be kicking us off on all things how to get started with Solana. So how about a warm applause for Solandy? Woo!
Thank you. Hello, GM Tel Aviv. How are you doing? Oh, I have my screen right here. That's perfect. I have the pleasure to talk to you about how to get started with Solana. So this talk is for everybody who has not interacted with Solana at all, and for those who do have development background but have not developed on Solana. So, let's get started. What do you need to get started on Solana? Step 1, you need to get yourself a wallet. Now there are different wallets out there. We have Phantom Software, Go Backpack. Who already has a Solana wallet? Put your hand up. Yes, so that's quite a lot of people. I have something for you. If you scan this QR code with your wallet, you can mint yourself an NFT for free. And for everybody who does not have a Solana wallet yet, look at all the people who got their phones out right now and remember them, because if you have problems setting it up, those are the people that you can ask for help and just start up a conversation. Hey, what's your favorite wallet? What should I install? Just go ask them. There will be this code again at the end, so don't worry if you missed that. I'm not going to go through the wallet setup process with you. The only thing that I want to say here is keep your seed phrase safe. So if you've never interacted with any crypto stuff, the seed phrase is basically the backup of your wallet. So if you lose that and you lose your phone or the installation, then you lost your stuff. But also, if somebody else has that seed phrase, they can just take all of your crypto. So you really want to keep that safe. Yes. Cool. So once you have a wallet, we can continue with step number 2. Get the Solana CLI. So there's a nice installation guide on the docs page of solana.com. Also not going to go through this. It's different for macOS, Linux, and Windows. Just go to solana.com and follow this procedure. And then in the end, ideally, in your CLI, which is a bit, oh no, that's going to be fine. You should have a Solana CLI installed. Since this is a bit cropped, I'm going to do this to make this better, maybe, hopefully. We'll see. Okay. So once you have the Solana CLI installed, the next step is to get yourself a wallet, a file system wallet, so that you can work with the CLI and Solana. So that would work with Solana Keygen. Keygen is one thing that comes with the Solana CLI, and then you can say new to create a new file system wallet, and I can specify where I want to store it. Let's say my keyfile.json. And if I do so, it asks me for a passphrase that just keeps my seed phrase more secure, but I'm not going to enter one. Again, here we see a seed phrase. Don't show this to anyone unless you're holding a presentation and you're not using this wallet actively. So we see we got a public key of 4DZE. This is my Solana address now, and I could work with this. The private key is stored in this file. So if somebody has access to this file, they can, of course, get access to my wallet. But such a wallet, such a file system wallet, is what I'll need to work locally with the CLI. So cool, we have this file system wallet now. Now, some basic commands are the setup for Solana CLI. So we can say Solana config set, and we say use the key my key file and use the network DevNet. So DevNet is a cluster of Solana validators for testing purposes, development purposes, DevNet. And if I enter that command, it uses this RPC, the devnet solana.com, and I can now request my balance with Solana balance, and I see, well, I do not have any Sol on this file system wallet yet. On DevNet, I can request some with Solana airdrop, and then I need to say how many or how much. And there we go, I got 2 Sol. Now my Solana balance will be 2 Sol on DevNet. Cool. What we can then do is some other basic stuff like sending those Sol around. I can do, but I now need a recipient, so I'm gonna just create myself a new address that starts with an A because I'm funny, I don't know. Okay, so this would now be a new address that I can send to, and I also have the key for that, and I can say Solana transfer, and then I say where do I transfer to, this address, that's the public key, and then how much, maybe 1.5 Sol. Boom, I can do that. And then since there's no Sol on this address yet, I need to say I allow this unfunded recipient, and then I send 1.5, not yet. Now I send 1.5 Sol to this address. We get the signature back. We can now look at that in an Explorer, for instance, on explorer.solana.com. There are several Explorers, but this is the one I'm going to showcase now. And it's a bit small. You don't really see that very well, do you? But we see what happened here. We sent 1.5 Sol to this address. Now all the details here, it's talking about transactions and whatnot. To understand what's happening here with the system program transfer, instructions, we need to understand the basics of how Solana works. So let's continue in our presentation with step 3. You want to learn about Solana. And I'm here to help you with that a little bit by talking about Solana's programming model. So, Solana's programming model, there are a few key concepts that you need to understand how to develop on Solana. One of them is accounts. Now you might have heard people say everything is an account, which is true on Solana, but what does it really mean? So you can think of an account as basically a file in a normal file system. So the accounts are the things that store some data. They come at public key, so at an address. That's the address of the account where all the data lives. And they hold some Sol. So each account can have some balance of Sol, and then they can have some arbitrary data, so just a bunch of bytes. You as the developer are responsible for, organizing those bytes, and the more Sol you put on the account, the more bytes you're able to store. That's going through the concept of rent. It's basically a deposit. You need to deposit Sol in order to be able to have the data storage available on Solana. Cool, so there are 2 important things to note here. Anybody can deposit, so from my wallet I can send to any wallet some Sol, that's fine, or to any account, but only the owner program of the account can actually remove the Sol, so get it back, send it to another account, and also only the owner can modify the data. Everybody can read the data, it's a public blockchain, everybody can just look at the state and see what is stored in those accounts, but only the program that owns the specific account can actually change what is there. Cool, so an account more technically, again an account has the key, so that's the address, Lamperts, that's the amount of Sol, and 1 billion Lamperts make up 1 Sol, so Lamperts is the smallest unit here, it's 1 billionth of a Sol. Some data, as I said, just some bytes, and then we note if that is a program, because also programs are just accounts. They're accounts with executable data. And then the account also stores which program, again the account of the program that is, has write access, so who is the owner. Cool, so let's talk about programs. That's what other blockchains consider as the smart contracts. On Solana we call them Solana programs. And a program is just a special type of account with an executable flag set to true, and it holds some bytecode. And that can be written in Rust, C++, or even Python compiles down to it. And programs are stateless. That means once I deploy a program, the data, so the executable, is written there, and it stays like that. In order to have actual state like data to your program, you need to use other accounts, like data accounts, for your program. They are then owned by the program, and the program can change them, but they're different accounts. This allows us to execute stuff in parallel, because if the program is never written to again, then it is only read, so that allows us to parallelize it in the runtime. And as I said, only the owner is allowed to modify. And for the programs to actually do something, an instruction needs to be called. So this executable bytecode defines instructions that can be called on the program. You can think of them as functions that you know if you're a developer in any other language, and those program instructions can then be invoked. So an instruction, we need to specify which program do we want to call, so we say which program ID, and then we specify which account it's going to use. This is another special thing that we need to do on Solana. We need to know the accounts up front, such that we can say which ones of those do we want to write to, so we need to get a write log. Again, that's important for the runtime to do parallelization. And then we can add some arbitrary bytes as data for our instruction, so it's like the function parameters when calling the instruction, that it does different stuff depending on the data. Okay, cool. Now, to actually send an instruction, we need to put it into a Solana transaction. A transaction essentially just holds a bunch of instructions, or just one, that's fine, and a bunch of other stuff that I won't go into now. But the idea is we can put several instructions into one transaction, and then that one transaction we can send to an RPC client, which is basically a server somewhere who knows the state of Solana, so it can simulate the transaction, and if it's good, it will send it to the next validator who produces a block, and then the validator actually executes the transaction and modifies the state, and that is then updated on all the validators. So that's the process. Maybe let's go through an example before I get to questions. Let's say we wrote a simple program that just has this one function increment, and it uses an account that has 1 byte as data, the count, and all the function does is just increment that count. So our client, our web app that we would develop, would now build this transaction to call the program. This will then be, the transaction would be sent to the RPC client, which forwards it to a validator, which actually executes it, so the instruction on the program is called, and the program then, since the counter account is owned by the program, can modify the state, and we have a new state in this account. Cool, so far so good. Are there any questions? Do we have the mic for audience questions? Are there any questions anywhere? I take that as a no, and you all totally get what I'm saying. Perfect. Nice, no one gets what I'm saying. That's important. Cool, next important concept, we have cross-program invocations. So a program can not only modify its own accounts, but it can just call another instruction of another program, such that that other program then can modify the accounts it owns. And In our example, our program could now call this other program via CPI, which then modifies another account that it owns. And this only becomes really powerful when we use program-derived addresses, or short PDAs. A PDA, that's another really important concept when it comes to Solana development, and I'm going to just tease a little bit. A PDA allows you to sign on behalf of the program. Now, we can sign with our wallet because we have the private key. Cool. A program cannot have a private key because all the state is public, and then anybody could just read the state and read the private key of the program. So that doesn't work. But a PDA, a program-derived address, allows a program to actually sign. And a PDA can also be helpful to organize your data. We'll get to that in a second. But let's first have a look at how such a PDA is created. It's basically just a bunch of seeds, so just some bytes, like strings or public keys, and then in the end, the program ID. And the program ID is what makes it clear which program it belongs to. So this program-derived address belongs to this specific program ID. And only this specific program can then sign for this account. There's some more magic in the background how that works that I'm not going to go into, but I do have some videos on YouTube that go into depth there if you're interested. So again, in a normal transaction, my account can do a signed transaction and the program can then update. But if we use a PDA, then I cannot sign for the PDA because there is no private key for it. So I sign this as I use an unsigned transaction, or I don't sign this for this account. And then the program can create the signature when doing a CPI to another program by just providing the correct seeds. Cool. Again, don't really have the time to go into depth how that actually works, but happy to talk to you about it, or watch some videos of mine, or come talk to me. The other thing that PDAs are really helpful for organizing your data, because we'll have to store everything in accounts. So let's take the example of a standard Web2 database. Let's say we want to store our users, each with username and email, and each user has one wallet that they use that with. So how can we do that on Solana to make accounts in a way that makes sense? Well, easy. We just create for each entry a new PDA with some static seed like profile, and then their wallet address, and then that makes clear that each user will have exactly one PDA that can then contain, for instance, this username and email stuff. So that's then our actual data, and the wallet address is part of the seeds that is used to derive the PDA. Cool. Questions to PDAs or CPIs? No? Great. Then I can move on. My last topic for today, tokens. Now, there are already programs deployed on Solana that you can use. So you don't need to deploy your own smart contract or Solana program just to be able to create tokens, for instance, because there are already programs that you can do that with. For instance, the token program. With the token program, you can just call an instruction on it, so that's all just client-side stuff, to create a mint, so that's a new token, and then it lives at an address that we call the token mint. And then there are other programs like the associated token program that is just used to derive an address for the associated token account for a wallet. Because every user, if they want to have a token, then we need to somehow store, well, how many of those tokens does this user have? And we don't want to store it all in this one massive account. No, we create one account per wallet. And that's where this ATA comes in, such that one wallet actually has exactly one associated token account. We use this associated token program to do that. And then this account, the so-called token account, holds the balance of the user wallet in that token. So it depends on the mint and that wallet and the token program, because there can be different token programs. Let's maybe first look at the derivation here. So the seeds for such an associated token account are the wallet address, the token program, and the mint address. So for each wallet and for each token and for each token program, there's exactly one address, and that is the associated token account. And it stores the balance, among other things. Cool. Then there's this third program, the token metadata program, that allows us to store some metadata, like to give it a name and a symbol to our token. Like if I wanted to make an Andy token, I could create this metadata account that then holds this information. So how it would work is I create a transaction with a bunch of instructions. First I need to create the account, then I need to initialize it as a mint account, so I call the token program. Then I create the associated token program, and then I mint some tokens into that token account. All of those transactions using those two programs, I can put into one transaction and then send that to the cluster. A mint account holds decimals, the supply, so how many tokens are there, and who can change, like who can mint. NFTs are just using decimals of 0. Decimals tell us how many decimal points I can have in a token. That's just used to display it nicer, and internally still use 64 for the actual supply. And there's also a freeze authority. Then there's also the token 22 program, the newer token program that allows us a bunch more features, but that is too much for this little intro. Metadata account holds some data like the name, the symbol, and maybe an external URI where you find descriptions and stuff that we can store in the metadata account. And with all of those together, we can create our token without actually deploying any program onto Solana. So that's one way how to get started. One more time, any questions? No, good. Cool, so what's next? I recommend that you go through some tutorials and look at some source code. I can highly recommend looking at the token program, because it's just such a basic program that is used in so many use cases. Like basically everything on Solana in one way or the other uses tokens. In the SPL, can you read that? Maybe make it a bit bigger. In Solana Labs, Solana Program Library, short SPL, we find the token, and inside token we have the actual token program. There's also the CLI and the client-side stuff, but in the token folder under source we find the actual source code. So that's the deployed program for token program. And what is interesting here is we could look at the instructions, how they're processed, or look at the state. State RS contains the information how the accounts actually look. So a mint account, for instance, contains the mint authority, which is a public key, or not present, so it's an option. There can be no mint authority if it has been disabled. The supply is the U64, the decimals, just to display them differently? Is it initialized, and who is the freeze authority? And so on, and then we find more information on the token account. The token account has the owner, the mint, and as we said, the amount, so that's the balance that I was talking about earlier. Yeah, so basically, go through some tutorials. If you get stuck, go look at the source code. And while you're here at the Hacker House, if you have any questions, do sign up for the office hours. I'll be here, there are other people here to help you out depending on which kind of problem you have. Also join the workshops. Me personally, I'll be doing one on how to write your first Solana program, so that goes a little bit more into depth. We'll have a little bit more time, and we can have a look at Anchor development. And then I'll have a second one in 2 days about compressed NFTs, which is new technology to cheaply mint NFTs on Solana. If you scan this code with your wallet, actually you just need to scan it, you don't even need to sign or anything, then that will mint my contact details into your wallet directly, so you can stay in touch with me. And otherwise, I thank you for your attention. You can have this NFT once again. And if there are no more questions, then I shall see you around this Hacker House. Thank you.